The fifth topic is again continuation of second derivative. We need to know the second derivative information. We had just done basics in the last video, that is topic number 4. But here they're asking us to graph with thoroughly, in the sense we need to do the first derivative, find the increasing, decreasing, maximum, minimum points, and then we have to do the second derivative, find the concavity, and then understand the graph. I will do one problem in brief, this one, and then I will tell you a shortcut method to easily find which is the graph given the function. Because the functions are given in the 4 options, you can easily choose the correct graph. I have done it already in the previous video, but I'll just repeat it in a while. So now to graph this, now it's very simple. I'll just show you over here how it's done. Now this is the function. Given function is over here, square root x squared plus 1. You need to derive it. I'll just write the formula root x derivative is 1 by 2 root x. Remember this always. And then over here it's a chain rule because there is another function x squared. This is also a function. So what happens is square plus 1 multiplied with the derivative of x squared, that is 2x. So you will get 2x divided by 2 root x squared plus 1. This is the thing. Now you can equate this to 0 and find the critical numbers. When you equate it to 0, this becomes 0. X is equal to 0. Okay. So then what next? So we have found the first derivative. Very simple, straightforward. You can do the signs. We have done this before. Critical number is 0. Take value less than 0 and greater than 0. Let me quickly take some value. Over here minus 1, over here plus 1. Put it in this. So minus 1 divided by minus 1 the whole square plus 1. Minus 1 remains. What happens over here? Minus becomes plus. It will be 1 plus 1. It will be root 2. I do not need to solve this. I just need the positive or negative. It's negative answers. Whereas if I take plus 1, see, this will be plus. It will be positive. Very simple. Now, next would be understanding it's decreasing when it's minus and increasing when it's plus. So I know basic of the graph, it's something like this. We need to know more, okay? So what do we do is, we need to, see, this is where it's increasing and decreasing. We need to do the second derivative. Now, the second derivative of this function over here, see, over here, this is simplified and written over here, okay? Now, we need to know the quotient rule. U dash V minus UV dash divided by V square. It is similar to the product rule where U dash V plus UV dash, but over here it's minus and then this denominator is added, squaring. Now let's solve it. U dash. Now I'll just show you over here. See, you have to derive the first function, the U, that is upper U and V, okay? U divided by V. What is U? X. You need to derive this. Then multiply with the V as it is. Root x squared plus 1. Minus, over here, keep the U function as it is and derive the square root x squared plus 1. Divided by square of square root x squared plus 1. Now here, see, this cancels off. And what else? You need to start deriving it. Over here, when you derive, you will get. So over here, it's very simple. It's 1. So this is gone. So only this is the answer. But over here, x will remain. And this derivation, we did it right at the beginning. Say this is the derivation of this. Over here, it's the same function we get again. It will be 2x by 2 root x squared plus 1. This 2 and 2 cancels. See, now the numerator needs to be simplified. You can do in various methods. See, there is a numerator in the right side. There is no numerator. Let's take a common. So before taking common, multiply and divide this numerator. X squared plus 1 divided by square root x squared plus 1. Only for this first term. I have not done anything wrong. See, imagine 2 by 2. I multiply it to 3. Does it make any difference to 3? No, because it's 1, isn't it? So this answer remains same. If I multiply and divide same quantity, it's the same thing. So it's fine. Now what happens over here when I multiply this? Power half and power half. It will be x squared plus 1 divided by square root x squared plus 1. And minus, over here it is x square divided by square root x square plus 1. Now, I hope you understand this is the step over here. And now you can just simplify it. You can just write this square root x square plus 1 together. This term minus x square, and this cancels. And this term can go down. It will be x square plus 1 multiplied by this term. Now over here, see, x power 1 multiplied by square root means half. What is the power? It will be x3 by 2 or 1.5. So over here we will have 1 divided by x square plus 1 to the power 3 by 2. Because we are adding the powers. Nothing means it's 1 and square root means half. Add it, you will get this. What next? Now we will find the critical numbers. Make it equal to, we will find the inflection point, but make it equal to 0. Now take this to the other side. What happens? It will be 1 equal to 0. Is it correct? No, it's wrong. So it cannot be equal to 0. Okay, double derivative cannot be equal to 0. That means there is no inflection point. Now let's take any over here. What it means is, see, it's concaving upwards. How? Take any point other than 0. See, take any point greater than and put it over here. It should be greater than 0 and not equal to 0. So just take, it should, if you solve it over here, x square plus 1 greater than 0. So x square must be greater than minus 1. So we can just take a value, say 3 or something. Test over here. It will be positive. So you're getting positive answers over here. And then we don't mind what is the answer. We just want other than 0. Even if you take minus over here, it will be positive only because square is there. Okay, we are getting positive answer. That means it is concaving upwards. So now it's concaving upwards from minus infinity to infinity. And over here, there is no inflection point we saw over here. Now, with all this information, see the increasing, decreasing concavity, you can come to the conclusion of this graph. So looking at certain things, you can easily find out this graph. Okay, that is how we do it. Now the easier method, which I already told before, instead of doing all that, see there are, okay, end behavior is there. End behavior means take a big number in the x-axis in the positive side. See, it's up to infinity. Say take 100 and put it over here. If this is keeping on increasing, that means it's going towards infinity. If it is increasing negative number, you get some negative 999, then it is decreasing. So this is the end behavior. Now imagine the graph is like this. If we take a negative value and put it in the equation, it would be minus value. The right side would be plus value. This is the end behavior part. Now there is no horizontal asymptote. Intercepts can be found out. All this can be found out, and ultimately you can zero down to the correct option. But there is one more easy method. You can just take out your calculator. You will have 4 graphs, isn't it? Because we have to graph. This is MCQ, topic number 5. Just choose x values. So I will choose, say, 4. Put it in this equation. The square root of x is 4. Sorry, I had to put 4 square plus 1. Now, what is the answer? Square root 17. That is 4.13. So let's see over here. 4 is about 4.13. Yes. If you take a proper scale and measure, you will get the correct answer. Let me take 0. Over here, 0, it will be 1, obviously. So that's the 1. And any value, say for example, minus 2, use the bracket, minus 2, the whole square. You will get square root 5, that is 2.3 somewhere over here. Yes, 2.23. So this is how you can easily graph as well. This can work, this whatever I just now told you can work anywhere. Now let's take over here, say I'll take value number 3 and put it over here. 3 plus sine 3. Since sine is there, make sure I put it in radian, shift mode and 4. And I will get now the answer 3.14. Yes, that is almost correct. Same way you can check all the other graphs and you can easily get it graphing. Otherwise, just do the method which we just now did. Oh, this is very important. First derivative, second derivative, and then you can easily understand the graph.